Okay, I've managed to find a classroom, although the microphone has disappeared. So I'm using my phone to talk here, but it should be fine. I'm pretty sure everything's working. All right. So there was a video, an additional video I said I wanted to record to sort of clarify what's going on in this circuit. What are we actually talking about? So I was discussing this with a couple of students at the end of class. So I wanted to throw this up here. So in the circuit we've been looking at today, we have we have some resistors and inductors. There's a few resistors, 1, 2, 3, an inductor, a capacitor, and a current source and a voltage source. So I need to give, it's probably wise if I give some context about what these sources are trying to tell us. So this is a phasor for the current here. And what that's telling us is that the waveform for this current source in time has the form 2 cosine of, I'm just going to put omega t. And normally there would be a plus theta or a plus phi, but that would be whatever the phase of the cosine was. So the magnitude of the cosine is the 2. And then the phase of the cosine being 0 degrees means this is cosine of omega t plus the phase. Here the phase is 0 degrees, so it's cosine of omega t plus 0. And then the 2 here is what carries the amperes, but it's telling us that this source, which I can call, I'll just call it IS, the value of IS has a current going upward whose value is 2 cosine of omega t. Now, depending on the value of t, this can be positive or it can be negative. So the current that this source is generating is varying sinusoidally over time, going from +2 to -2 and back again at a frequency described by omega. So omega is the angular frequency. So the period of this sinusoid t is 2 pi over omega, whatever that is. So every 2 pi over omega seconds, the current has returned to whatever value it was at the 2 pi over omega seconds ago. So at time t equals 0, this source produces 2 amperes up. At time t equals 2 pi over omega, it is again 2 amperes upward. In between, it goes down to -2 and back up to 2 every 2 pi over omega seconds. In order to be able to write phasors like this, all of our sources need to have the same base frequency. So if we express this Vs, the voltage waveform Vs here has to be 6 cosine, again, omega t. If there was a phase, we would add it on. And I would still want to write it in radians, even though the circuits people write it in degrees. And so this Vs is 6 cosine of omega t volts. Oh, and you couldn't see me write t equals. The period, capital T, equals 2 pi over omega. So every 2 pi over omega seconds, forgot I had it cut to the right edge here, kind of zoomed in part of the board so that it's easy for me to write at an appropriate size here. So at time t equals 0, V2, node V2, is 6 volts higher than node V1. As time passes, V2 eventually becomes 6 volts less than V1 at time t equals pi over omega. And then it's back to being 6 higher than V1 at time t equals 2 pi over omega. So I said pi over omega is when this voltage is -6, because that's halfway through the period. The voltage between these 2 points is equal at the quarter periods. So at pi over 2 omega and 3 pi over 2 omega, and then continuing periodically, right? So we have a sinusoidally varying voltage, and we have a sinusoidally varying current in this source. And so actually, I think I'm going to cut my first recording here. We think if there's anything else to say, I'm just going to continue this in a separate video, so I'm going to cut it at this moment. And so I don't think there's too much more to say currently, but this is the nature of the sources that we're talking about. The nature of these sources and the frequency of them is important to determining the actual value of the inductor and capacitor here. In this circuit, the inductor and capacitor have already been converted to phasor or to impedance form. And so in this picture, we aren't given omega, and so we don't actually know what the pure inductance and capacitance of these are. We do know what they are in terms of omega, but I'll talk about that after I cut the video for a second.